This video looks at 5 examples of simultaneous equations. Now, in simultaneous equations we have 2 equations in the question with 2 unknown letters in. Now, there are various ways of solving these equations, and I'm going to suggest one way of approaching it. Now, first of all, look at the y part of the equation. The first aim is to make the number of y's match in both equations. So, if I were to double the first equation, I would get 10x plus 6y equals 70. If I then triple the second equation, I get 9x plus 6y equals 69. So I now have the same number of y's in both equations. Now, I've got a plus 6y and a plus 6y here. They have the same sign. If I now subtract the second equation from the first equation, watch what happens. 10x take away 9x is 1x. The 6y's cancel out. And 70 take away 69 equals 1. So 1x equals 1, i.e. x equals 1. So we found one of the letters. I now just want to find what the second letter is, i.e. y. I pick any of these equations. This looks the simplest to me. Now, because I know x is equal to 1, I can replace the x here by 1. So 3 lots of 1 plus 2 lots of y equals 23. Now 3 times 1 is 3, plus 2y equals 23. Because I have to add on 3 to get to 23, 2y must equal 20. In other words, y must equal 10. So x equals 1 and y equals 10. These are the solutions to the 2 simultaneous equations. In the second example, I know the signs are different, but we approach it in the same way. I want to get the number of y's to be the same. Now, in this case, if I merely double the bottom equation and keep this one the same, so I'll keep this one the same, and double this equation here, 2x plus 2y equals 12, we now have the same number of y's, albeit with a different sign. Now, to make different signs cancel out, we just have to add the 2 equations together. 4x plus 2x is 6x, minus 2y plus 2y cancels out. 18 plus 12 is 30. So 6 times x is 30, x must equal 5. That is one of the variables, but if x equals 5, if I pick the simplest equation of these 4, probably this one here, x is 5, 5 plus y equals 6, therefore y must equal 1, because 5 plus 1 equals 6. So these are the 2 solutions to the original simultaneous equations. And in the final one, even more negatives, but again focus on the y's. If I double the bottom equation, I will get 4y, which will balance off the 4y above. So I will keep this equation the same. I will double the bottom equation, minus 10. The signs are different, but I've got 4y in both equations. Now, when the signs are different, we have to add together the equations to make them balance off. Now, I must be very careful here. Now, minus 3x plus 2x is minus 1x. 4y and a minus 4y cancels, and 11 and a take away 10, 11 take away 10 is 1. So minus x is 1, therefore x must equal minus 1. So that is one of the solutions to these pairs of simultaneous equations. But if x equals minus 1, if I pick, for example, the first equation, x is minus 1, minus 3 times minus 1 goes to plus 3. So 3 plus 4y equals 11. This must equal 8. 3 plus 8 equals 11. So y must equal 2. Because 4 times 2 is 8, plus 3 is 11. And these are the two solutions to this pair of simultaneous equations. So to summarise, look at the y part in each equation and think, what can I do to the equations to make the numerical part of the y's equal each other? And then, if they've got the same sign, we subtract. If they've got different signs, we add. The y's therefore cancel, so we find x, and having got x, we can then find y by putting x into one of the equations to find what y must equal. The final two examples I've classed as more advanced, and it actually goes under the name of substitution. Now this is the main equation here. It's got x and y's in. However, I know from the first equation y equals 2x plus 1. So I can replace the y in the second equation by 2x plus 1. So x plus 2 lots of y must equal 17. I then expand the bracket, simplify, subtract 2 from both sides, therefore x must equal 3. And then for the easy part, if x equals 3, y must equal 2 lots of 3 plus 1, which equals 7. And these are the solutions to this pair of simultaneous equations. The final example is similar. We have a main equation and a y equals equation. So we go to the main equation and we replace the y by whatever we're told it equals. We're told y equals x plus 1, so that y is replaced by x plus 1. So x squared plus 3 times y equals 1. I expand the equation, and then because it's quadratic, I want to make the equation equal to 0. So I subtract 1 from both sides. This equation factorises. Because 1 times 2 is 2, and 1 plus 2 is 3. Therefore, the solutions must be x equals minus 1 and x equals minus 2. Because if you factorised, the solutions are the numbers in the bracket with the sign change, because minus 1 plus 1 equals 0 and minus 2 plus 2 equals 0. And then, to finish off, y equals x plus 1, so when x is minus 1, y equals minus 1 plus 1, which equals 0, or if x equals minus 2, y equals minus 2 plus 1, which equals minus 1. And these are the two pairs of solutions to this pair of simultaneous equations.